How's it going, everybody? Welcome to another math tutorial. It's just after spring break, so I'm pretty tired. Don't really want to do this. I gotta start locking in, getting back in that grind set mentality though. So yeah, it's first tutorial back, and we're gonna be talking about some more AP Calculus Unit 8. And the first topic we got is called rotational volume. So I don't know how to explain it. We just got to jump into it and we're going to figure it out. So basically there's two methods. There's the disk method, where this is the formula here, and then there's the washer method, which this is the formula. And we're going to get into it in a minute, but first let's look at this. So for our example, when I let R be the region bounded by y equals e to the x, the y-axis, and y equals 6. So we're going to draw a little bit of a diagram. So e to the x looks something like that. Y equals 6. We'll just say it's like right here. So we're going to color that in. So let's see. Find the volume if F is rotated around the y-axis. First, y equals e to the x, x equals 6, y equals 0. Oh wait, y equals 6, I'm tripping. Y equals 6, and then this is x equals 0. That's something you always gotta remember, because it can get a little confusing. Alright, so we're gonna be rotating around the y-axis, which means we're gonna be going around this way. So basically what that's going to do is that's going to kind of mirror it around the y-axis, just like that. And then it's going to rotate, so we're just going to put little circles here to show the rotation. Make sure that you kind of like, oh actually you can just do this one in the middle. A couple circles, and then make sure you have one where you mark out the radius, because that's what we're going to need in a minute. So basically the disk method is for when things are solid. So let's say I'll just put solid, and then here hole, and then so the washer method is when things have a hole in them, or like something like this. Since this one is a solid, there's no hole in it, we're going to be using the disk method. So let's write out our formula. Area, thickness, which is dx or dy. So yeah, so what's the area of a circle? Pi r squared. We're going to fill that in. And our circles, their thickness is going upwards or downwards? They're going upwards on the y-axis. So turn that into dy. Now what we got to do, we got to find the radius of this circle. And actually, it's a little bit easier if you put it on the positive quadrant. So I'll put it over here. So how would we find this radius? Well, hold up. Okay. Bless me. I'm just kidding. So, is that something people say? I don't know. So we're finding the radius of this. Basically what we're going to do is take the right curve, subtract it by the left curve, and first things we got to do is we have to have y equals e to the x in terms of x, so it can fit in with a dy. So this would turn into natural log of y is equal to x, because we only want y's in this function. So we're going to get the natural log of y minus 0, right curve minus left curve. So we got natural log of y minus 0 is equal to natural log of y. So that's going to be our radius of the circle. And now we got to plug in the bounds, which is from, hold on, let me just double check something real quick. Okay, yeah. So basically, since it's in terms of y, and the circles are going upwards, we're going to go from here to here, 1 to 6. So that's the bound. And then there's our answer. Now you can plug that into a calculator or whatnot. But for now, we're just going to move on. Now rotate around the x-axis. Alright, so let's redraw the diagram. Y equals e to the x. Y equals 6. X equals 0, 0. Color that in. Oh shoot. Went a little bit too low. Should be at x equals 1. Where this crosses over. So now we're rotating around the x-axis, which means we'll be going this way. So it should look something like this. And we're rotating around the x-axis, so it should look something just like that. So since this one has a hole in the middle, we're going to be using the washer method. So what that looks like is, let's draw the formula down here. We got pi r squared minus pi little r squared, and then thickness dx or dy. So looks like we're going. All right, let's fill this out first. So we got. All right, and a little hint. Usually one of these is going to be a number, and the number is going to be the one where it's a square. So sometimes like the inside or the hole will be like curved, and then sometimes the outside will be curved, and then the inside will be kind of square. Usually the one that's square, that is square, will just be like a number, and then the one that is curved will be like a weird right curve minus left curve or top curve minus bottom curve type of ordeal. So yeah. So first things first, we gotta find the area of the big circle, which was the big R, big circle. So pi, then it goes from 6 to 0. So pi 6 squared minus, we got the little square here, which is, or the little r, which is gonna be top curve minus bottom curve, which is y equals e to the x minus, or e to the x minus 0. Oh, there we go. I don't know if you heard me or not, but so this is what we got. Radius of the big circle is just a number. Sorry, my microphone died there for a bit, and then the x is top curve minus bottom curve, where it's curved, which is going to be in the hole this time, and thickness, which is going around along the x-axis. So the x, and now that I showed you all this, let me just double check my answers, just so I'm not giving you guys wrong information. So alright, looks like it's alright. You just gotta remember to put it in the bounds. I low-key forgot to do it, so that's a good reminder. Maybe we should write over here, just a reminder. Put in bounds always. yeah, so the bound is going to be x equals 0 to this point right here at x equals 6. So what is x equals 6? Well, we got to figure that out. So so y is equal to e to the 6. Or am I mistaken here? Hold up, I think I may be a little bit mistaken. So So we know for sure it starts at 0. Then looks like the radius comes up to here. Or x-axis. We start on the x-axis at 0. Then we go this way to this point right here at y equals 6. So x is equal, we're going to use this equation up here. So x is equal to the natural log of y, because it moves over here. Yeah, so y, it goes to y equals 6, and when y is equal to 6, natural log of y is equal to x. So there you go. Natural log of y, then there's our answer. And that's a pretty basic tutorial on how you do rotational volume. Alright, on to the next. We got cross-sectional volume. Now I do not like this one at all, but we're gonna do it. So let's just get into it. So we got our base region here. We got y equals x plus 1. I'm gonna draw this one nice and big. Okay, apparently I can't draw a straight line, so let's go here, here, here. Y equals 1. X equals 3. We'll just say it's over here. Now this is what we got. Little triangle. Okay, so here's the, looks like we got cross-section squares are perpendicular to x-axis. So the squares should be going like that. That's kind of a square. And here's our formula. So we got A to B, the area of the cross-section, thickness, and then that is equal to our volume. So let's go ahead and do that. So this goes from 0 to 3. So that's our A to B. And it's on the x-axis, so that's going to be a thickness, so that's what we got to look at. 0 to 3. What's the area of a square? Well, that is side squared. It's kind of good to write it out. And then the thickness is dx. Okay, so how do we find the side though? So the side of a square, or the side of this square is going to be the top curve minus the bottom curve. There it is again. That word's gonna probably haunt me for a while. I don't hate hearing it, but I don't know. It just gets annoying after a little bit. But okay, I don't even know what I'm talking about. So we got y equals x plus 1 up here and y equals 1. So that's going to be x plus 1 minus 1 squared dx. And then believe that's all we got to do. Let me just check my work from the rest of the day. I mean, the truth is, like, I don't really be studying this stuff that much. This is like the only time I study when I'm making these videos, so I gotta check the answers sometimes. Not a master yet, but hopefully I'll become a master by doing this stuff. And it looks like I'm starting to become a master because that was right. And I don't know why I put the demon there, because that was actually pretty easy. I'm actually starting to get pretty good at this stuff. Ooh, necklace appears out of nowhere. But yeah, let me just talk about how much like making these tutorials has helped for me. Here's my most recent quiz, where I made the video, my last video about like average value and finding the area of these things. I did that like last week before spring break, right before this test, and I mean, it went good. As you can see, we got a 4 on these parts. Then I put this in the calculator wrong, little mistake, and got all this right, and I got a 3 and a 4. But wait, that's not all, because I got a 0 on something, because I didn't do it. I skipped it because there was no time, or I didn't have enough time left. And just guess what? My teacher said the day before, she was like, since we just learned this stuff, we're not going to count it on the test. So I was like, okay, cool. I'm going to just skip this one because I don't have that much time. And then, so yeah, I skipped it, and then she counted it. So now, instead of having a 3.5 like I should, I have a 2.33. So thank you, teacher. Appreciate it. And I asked her today, I was like, why didn't you count it? And she's like, oh, we went over it enough. I changed my mind. Stop complaining. Get good on the next test. I was like, oh, are you serious right now? But right now I'm gonna do this question, and we're gonna learn my mistakes and see how I could have gone and should have gone the grade that I should have gone. That didn't even make sense, but we all know. And math teacher, I'm coming for you. This next test, I'm gonna destroy it, and then I'm gonna come and replace this test, and then yeah. My grades are already pretty high though, so this one didn't affect it too much, to be honest. But yeah, let's get into it. So let R be the region in the first quadrant bounded by the graphs f of x equals 1 minus x squared, and g of x equals 1 minus x, as shown in the figure. Region R is the base of a solid. For the solid, each cross-section perpendicular to the y-axis is a semicircle. Find the volume of the solid. Alright, so looks like this is 1 minus x here. This is 1 minus x squared. Gonna give this a little coloring in. Boom. Draw a little semicircle. Alright. And then we gotta remember the formula, which is A to B, area of cross section, so there we go. So looks like the thickness is going to be on the dy axis this time. So dy looks like it goes from 0 to 1. So what's the area of a semicircle, you may ask? Well, it's pi r squared over 2. Now, the thing about this problem that we got to find is what is r. And once again, r is going to be right curve, well, top curve minus the bottom curve, which in this case, since it's a dy problem, is right curve minus left curve divided by 2. So r is equal to 1 minus x squared minus 1 minus x, which that would give you the diameter. Then put that over 2, and you should get the radius. So radius is half a diameter, in case you didn't know. You guys should know that though, because you're in calculus, or unless you're just watching this video just to learn. That's pretty impressive. Not many people doing that nowadays. So that's what our radius is. So you can just plug that into the problem. And then we can just say this is over 4, can't we? Actually, you know what? I don't even care. I'm just going to keep it like that. I don't really want to think right now. I just want to go and eat a snack. Oh, jeez. Forgot to put these in terms of y. Little rookie mistake. Alright, so let's fix that. Y is equal to that. Y is equal to that. Now, we're going to go y minus 1 equal to x, negative x squared. Negative y plus 1 is equal to x squared. X is equal to square root of negative y plus 1. Then we got this. So y minus 1 is equal to x. X, or negative x. X is equal to negative y plus 1. Alright, there we go. So let's replace these functions. Alright, and that should get us to our final answer. So pi square root of negative y plus 1 minus y plus 1 over 2 dy. Now I'm going to open up the answer key, see if I did it right. See if I'm having any trouble yet. This r needs to be squared, can't forget that. And that is the right answer, folks. You know, maybe I shouldn't have skipped it. That was actually pretty easy. I don't know why I drew that demon logo earlier on the cross-sectional volume thing. That was pretty easy. And I would like to refer you guys to my other video. Should be my last video I made on, I don't even remember what it was on, but just watch it. It's about average value, find an area of these thingies, and should help you with Unit 8 stuff. But yeah, that's about it from me. Have a good day. I'm going to go take a bath, eat a snack, and yeah, that's about it. Thank you everybody for watching, if anybody is watching. And yeah, bye. Bro fist. Boom. What am I doing with my life?